200. The PIC10F200. Oh, PIC10F200. The PIC10F200. Whoa, wait, it doesn't go in your...
Hello and good evening, everyone. Thank you very much for tuning in. So once again, I am experimenting with my PIC10F200 microcontroller, and please check out the playlist on my channel entitled PIC10F200, and I have about 20 or more videos where I'm playing around with this chip. Okay, so what am I doing today here? Where do I begin to explain? Well, this is another blink and LED program. This is GP0. This is GP1 with this orange connector here. Actually, this is GP0. It's configured as an output. This is GP1. It's configured as an input. And so I wanted to write a program where when the input receives 10 pulses high, it will store that value of 10 in a counter, at which point it will light an LED, and then the LED will stay on for 10 pulses and store that value in a counter, and then the LED will go low for 10 pulses, high for 10 pulses, low for 10 pulses. So it's a blink sketch, and the pulses are coming from this 555 timer. This is the output of the 555 timer. It has an LED so you can see what it's doing, and the output of the 555 timer is going into the input pin, which is GP1 on the PIC10F200. The nice thing about the way I set up this kit box is that I can control the blink rate with this resistor, so I can change the speed at which it blinks. Alright, so here is the code I developed, and I will go through it methodically. I'll start here. Here's the blink program, where I bit set F the LED. Then it goes to a delay routine. That's what all of this is. But it's more than that. But I'll get to that. And then it returns back up here. And a bit clears the LED, turns it off, and then delays again, returns, and it goes back to the main loop, and it continues to cycle through and blink the LED. But when it breaks into the delay routine, I have set up a counter. I set it up here in a file register location in RAM, and I start out by just clearing it back to 0. And then I bit test to see if GP1, which I've called detect, I set that up here. I bit test GP1 to see if it's set or high. If it's not set, or if it's not set, it'll go to the next line and stay in this loop until it is set. Once it's set, skip if set, it'll skip the next line, which breaks it out of the loop and goes to this line of code, which is a routine that I call wait for load, or wait for low, because when something goes high and you test for it, you have to test again to see if it goes low before you can release it. So we're going to test if this detect, or GP1, goes low. So we're bit test file skip if clear. We're waiting to see if this detect pin is clear. Once it's clear, it'll skip this next line. Otherwise, it continues to iterate here until GP1 is clear, or detect is clear. Then it increments this counter, which we cleared up here. Then it moves the value of decimal 10 into the working register. And without going into explaining X or WF, which really warrants a bigger explanation, but I won't go into that, this code basically is going to test whether the value of 10 stored in the working register is equal to the value in the counter. And then once they are both equal to 10, it'll bit test file skip if set. And what is it skipping that is set? It's skipping the 0 bit in the status register. So this is actually an arithmetic operation. And if you look in the data sheet, this instruction or mnemonic operand is applicable to the Z bit of the status register. So once the counter is equal to 10, it'll skip, it'll break out, and bit test file skip if set. If it's set, means the Z status bit went on, then it'll skip this next line of code and return it'll return from the subroutine, and it'll go back up to the main loop. But if the counter hasn't reached 10, it won't skip the next line, and then the next line here is go to the delay loop. So it'll go up here and detect if the input pin is high, and it'll iterate through this again until the counter accumulates up to 10, at which point it'll return it back to the main loop. Each time the bit is set, it it stays on for 10 pulses. Every time it goes low, it stays off for 10 pulses. Okay, so next I will show 2 video clips I took of my breadboard setup, where I am testing this out with a push button, a debounced push button module. It's not visible in this picture, but there's a video clip showing me manually testing the code in the PIC10F200, and then there's the video showing where I have added the 555 timer in place of my finger.
Okay, so this is GP0, the output pin, and this is GP1, the input pin. And the input pin is receiving a signal off of this module. And when this input pin, GP1, receives 10 high pulses, the light will go on, and the light will stay on for 10 high pulses, and it'll stay off for 10 high pulses. So let's see if we can hook that up to a 555 timer. And by that I mean hooking GP1, the input pin, up to a 555 timer. And the 555 timer is adjustable, and I can adjust the speed at which it blinks. Alright, so pointing with my pencil, here is the 555 timer output, which is being sent into GP1, and here is GP0, which is an output pin on the PIC10F200 that will light up for 10 seconds and go low for 10 seconds. Now I can change the speed of the 555 timer, so you'll be able to see how the GP0 will go on and off faster as I make the 555 timer blink faster.
The PIC10F200, oh, PIC10F200, the PIC10F200. Whoa, wait, it doesn't go in your mouth. Microcontrollers are not tasty. Tweedledee, smash the like and subscribe. Bro, 2-bit electronics. Ooh, mama, 2-bit electronics. Yabba dabba, 2-bit electronics. Oh, 2-bit electronics. Wow, wow, wow. Wow, the PIC10F200, the PIC10F200, oh, the PIC10F200, the PIC10F200, oh wait, it doesn't go in your mouth. Microcontrollers are not tasty. Tweedledee, smash the like and subscribe. Bro, 2-bit electronics, ooh mama, 2-bit electronics.